Hi, my name is Asmit and today I am going to discuss with you this question of the LeetCode. So let's start. The question is finish time of the task 1. So you are given an integer n representing the number of tasks in the project. Means you have to finish the n task and the tasks are numbered as from 0 to n minus 1. And these tasks are connected as tree rooted at task 0 means you can consider it like a DAG structure you can say or a tree structure in which at the end there will be only one root node and that would be the task 0. This is represented by the 2D integer array edges of length n minus 1, where edges u, v indicate task u is the parent of the task v. One thing to note is that whenever you have given the tree, then be sure that the number of edges in that structure will definitely be n minus 1. Okay, and there would be a single node that will be the root of the whole tree. Okay, you are also given that the U is the parent of the V. So you can think of directed edge, structure similar to the directed edges. Okay, so now you are also given an integer array base time of length m where base time of I represent the time to complete the task I. Means for every task you have some base time that is needed to complete that task. The finish time of each task is calculated as follows. There is the difference between the base time and the finish time. Both are different. Base time is the minimum time that is needed for the task, while the finish time is calculated as followed. So, to calculate the finish time, these rules are followed. Like if the node is the tree leaf, like if the node is leaf node, then its finish time will be base time of I, while if it is not the base, then you have to perform some steps and thereafter you will get the finish time. So let's have a look on the steps. It is saying that let the earliest be the minimum finish time among its children. Focus on this line, minimum finish time. It is saying that for the children's, you have to find out the finish time, not the base time. There is the difference between the base time and the finish time. So keep the difference of both of them. And the latest is the maximum finish time among its child. Thereafter, you will calculate this own duration value, which will be this one. And the finish time will be calculated as follows. That is the maximum finish time among its children plus the own duration time. By this way, you will have the finish time of each nodes in the tree. Thereafter, you have to return the finish time of the root 0. So, this is the whole problem statement. Now, let's have a look in the test cases. You have given n the number of nodes, the edges 0, 1, 1, 2. In 0, 1, 0 is the parent of the node 1. In 1, 2, 1 is the parent of the node 2. You have also given the base time in which base time of 0 is 9, 5 and 3 respectively. You can read the description as well. The task 2 is the live task. So the finish time will be the base time its base time itself, that is 3. For the task 1, you calculated the earliest and the latest finish time, not the base time of its all of its child. Thereafter, you calculated the own duration and then you have the finish time, that is this. So by this way, you have the finish time of this node as well. When you will move to this node 0, you will again perform the same procedure and you will get this value. This is also an example like these 1 and 2 are the leaf nodes, so their finish time will be equal to their base time. While in the case of 0, you will calculate the minimum or the what is there, the earliest finish time and the latest finish time. Thereafter, you will calculate the on duration and you will have the finish time. So, one more test case you can read it as well. So, now let's start with the intuition of this problem. So, the first thing is that whenever in a problem you see that there is the mention of the tree structure in which there are n minus 1 edges, then you should think that you have to create two arrays. One will be the parent array and the other will be the degree array. Why we are doing this? There are two approaches. Like for the given structure, you can also create the adjacency list. Like for the node 0, what are its neighbor? For node 1, what are its neighbor like 0 and 2? And you create the adjacency list, but the creation of adjacency list is a high memory intensive task. So you should try to avoid creating the adjacency list. Okay, so and if there is the mention of the tree, then you can refer this approach. Like you will have a single 1D array in which you will be pointing to the parent of any node. So let's move to the board. Let's say you have a structure like this, in which you have nodes like this. So this is a structure. This is a tree-like structure. Okay. So what best thing about the tree is that for every node you will have only one parent. Like if this is the node, then it has only single parent. For this node, this is the single parent, and for this one, this is the single parent. For this node as well, this is the single parent. Okay, so you can create a single 1D array like this. Let's give it some name A, B, C, D, E. So if you are creating a parent like array like A, B, C, D, and E. So when you will be storing the parents, you will store something like this. Like the parent of E is B. So you will be storing here B. For D as well, B is the parent. For C as well, B is the parent. For the node B, A is the parent. And for the node A, there is no parent. So you can simply write -1. So this is the parent array. Similarly, you can create the degree array as well. A degree array is simply keeping track of how many children a node have. Like whenever you find any parent, just increase its degree. Like in this case, the degree is 1 as it does not have any children. Its degree is also 1. Its degree is also 1. While in the case of B, the degree of B is 3 because it has 3 nodes. While in the case of A, you have 1 degree. So, firstly, do the code of these two things like creation of the parent array and the creation of the degree array. Okay, now let's move to the coding part. Firstly, we will creating a parent array and a degree array and a degree array. New int of size n for loop int I बराबर 0 I less than just travels to edges itself. Uh, for the sake of simplicity, let's consider node 1 as E of 0 and into node 2 as E of 1. Since it is mentioned that the task U, uh, keep it simple, let's consider U1 and V1. So it is mentioned that the U1 is the parent of the task V1. So uh, let's do whatever is written there. Like the parent of V1 is U1. It is mentioned that the task U is parent of task V1. Write it also as well. U1 is parent of V1. And since U1 has a children, so just increase the degree of U1 as well. So by this single for loop, you have completed this task. So let's print this one as well. Uh, you can do like this system.out.println. Sorry. Uh, parent arrays dot to string parent and degree is array dot to string degree return -1. Let's run this one. You can verify it as well. Whatever I have said, you can cross check on your own. So let's move to the another part. So what I am thinking of, I am trying to use the queue for this problem. And why using queue? The first reason is that if I am using the queue or a BFS like approach, then I will not be using any recursive space, like there would be no stack memory used in the iterative approach. And the other reason is that the iterative approaches are much faster than the recursive one. So I will try to use the iterative as in this problem. So what I want to do is like since I have calculated the degrees, like I have the degree of all the elements. So what I can do is, sorry, I have done a mistake. Here it should be 0 because there is no children of these nodes. So the degree of these leaf nodes will be 0. So the degree being 0 will be our criteria to insert elements into the queue. Uh, why? Because somehow we have to fetch the elements. We have to take into the consideration some nodes, and we can set the criteria like if the degree of any node is 0, then we will be firstly analyzing it, and once the analysis is done, we will be pulling out that node from the queue as well. So I will be creating a queue in which I will be inserting all the nodes which has degree 0. So let's start. Let's take the firstly I have inserted in the queue C, D, uh, and E node. So these three nodes, let's say I have inserted into the queue. And after insertion, I will be fetching it as well in the sequential order. So let's say I fetched C firstly. So when I will be doing analysis of this node, then I will try to find out 3 points about this node. So and these 3 points are, the first one is the minimum finish time, and the other will be the maximum finish time, and the the third one will be the finish time of the node itself. Let's explain me this again. So let's say you have a node. So for each node, I will be taking 3 pointers. The first one will be the minimum time, minimum time. Thereafter, I will have the maximum time and I will be have the self time. So uh, this first pointer will be the minimum finish time, not the base time. The minimum finish time of all of its children. This will be the maximum finish time of all of its children, and this will be the finish time of the node itself, which will be derived using these two values. Okay, so let's firstly do these three things like creation of the queue and inserting the elements whose has the degree 0. And once I have these three values for the node, then I will decrease the degree of the parent as well. Like once I have done, I have fully processed this node, then I will consider that this edge has removed and the degree itself also get decreased by 1. Similarly, when the processing of this node will be done, its degree will get decreased by 1, and when this processing is done, its degree becomes 0. And when the degree will be 0, this will become eligible to get into the queue for the further processing. So let's move to the coding part. Firstly, create a queue, and I will be src barabar 0, src less than n, src plus plus. If degree of src is equal to 0, then insert it into the queue. And since I have said that I will be creating three pointers for each node, so let's create an array for it. Uh, you can call it as mat and comma 3. Since the degree is 0, it means this is the leaf node as well. Leaf node. And since it is a leaf node, then the finish time and the minimum finish time of its child and the maximum finish time of all of its child will be equal to the base time of I. So let's rename it as like time, so that I don't have to write it the whole word again and again. Mat of src comma 0 will be time. This is what? This is the minimum finish time. All children's, not node itself. Mat of src comma 1 will also be time. This is the maximum finish time of all childs, not node itself. Thereafter, I will be calculating the finish time of the node itself. It is the finish time of node itself. So now let's start our BFS traversal. While node of q dot is empty, I am creating these variables out of out so that it get a little optimized in terms of the memory. So calculate the size of the queue while size minus greater than 0. RC is q dot remove. Like if this is the case, then and you have inserted C, D, and E, then you are firstly processing this node. Okay, so let's start. This is the SRC. Now you have to for each node. Let's say if SRC is equal to 0, then you have to get out of the loop. Why? Because there is no parent to move further. Okay, so this is the SRC. Now you have the node. Now you will be considering all of its child. Now let's consider the parent as well. Int node parent. Node parent will be parent of SRC. Okay, or you can simply write no need of creating node parent. You can directly use the array itself, the parent array. So now let's start. Uh, since equal to 0, you have to calculate the minimum time of uh, wait a minute. I have created the mat of parent of SRC, comma 0. And this will be what? This will be the min finish time of all childs. Thereafter, mat of parent of SRC, comma 1. This will be max finish time of all child. So when you will be calculating the minimum finish time, you also have to do one thing. Uh, let's move to the constraint. It has been given that the base time is this and the finish time of all the task is guaranteed to be 2 raised to power 53. And in the solution, in the return type itself, it is mentioned that long is expected. So instead of creating the integer array, we should create the long array. Otherwise, we will be out of you can say the integer overflow. I barabar 0, I less than 10, I plus plus. Mat of I comma 0. This is the minimum finish time, so I will initiate it with the maximum value. And for this one, with the minimum value as well. So now let's calculate the minimum finish time of all of the childs now we are considering the minimum finish time for the parent, and this 0 is for the children's info, not the parent info. So this will be math of you will have some existing value here. So you will take into the consideration the existing value as well as the finish time of the children's. Focus here. I am using SRC and 2. Like I am focusing on the finish time of the children's. Okay, so now let's calculate this one. Math dot max of math of parent of SRC comma 0 mat of SRC comma 2. So this is the approach. And one thing more, since I have done the processing of this node, since the processing of this node is done, I will be decreasing the degree of this parent node. So let's do that. Degree of parent of SRC minus plus. And if degree of parent of SRC is equal to 0, then it is eligible So we inserted into the queue parent of src, and since I have processed all of its child, since I have processed all of its child, and in the first two pointers, like this one and this one, I have the minimum finish time of all of its children and the maximum finish time of all of its children. So the time is to calculate the finish time of the node itself. So right here, finish time of node itself, map of parent of src comma 2, and this will be latest time, mat of parent of src comma 0, src comma 1 plus this one latest minus earliest, mat of parent of src comma minus mat of parent of src comma 0 plus time of the node itself. So this is the whole code. Now you have to return the mat of 0 comma 2. So let's try to run this one. Wait a minute. Sorry, here should be time of src. Let's look what has happened. Uh, I have initialized the minimum and maximum value. Degree calculation is correct. Wait a minute. Parent of 0th node should be minus 1. Parent of 0 should be minus 1. I have the base time. So let's do a debugging as well. You have this parent of src min src comma 2. Let's run system.out. src will be parent of src plus min child right of parent of src comma 0 plus max child mat of parent of src comma 1 plus self, that is the finish time of the mat of src comma 2. Okay, let's have a look. 6 6, what is it? 6 7. I initialized is here. Thereafter, at the 0th, I calculated. Oh, sorry, here should be 1. Let's try to run this one. That's all about the problem. If you like the content, then like the video. Thank you.